Okay, so Andy's now going to talk us through the diagnostic elements of the challenge we've set our two speakers. So, on you go.
Okay, thank you very much. I'm just going to flick it onto this. As you mentioned, I'm going to talk about diagnostics and their use in potato production. And it really, John has described how visual inspection is the core to trying to assess crops and their quality for disease, both in the field and at harvest. But there are always limitations to many things, and visual inspections also have their limitations. And one of those might be that the pathogen or pest that's causing disease causes symptoms that are very similar to another pest or pathogen. So that's one of them. The other is that sometimes a pathogen might be present without causing disease. And also when we're looking for these microbes or pests, it can be very difficult. You see the paddock there. Actually detecting one of these might be quite difficult. So I was asked to make this interactive, so hopefully you're all awake. And we'll move on to the next slide. And in this slide, I'd ask you to have a look at these three panes. These are tubers from a plant 1, 2, and 3. And they're just tuber slices that have been taken, photographs of them. Some of them not in great order, obviously. But what I'd ask you to say is, can you tell which ones are carrying a pathogen and which one, and what the pathogen actually is? So hands up if you think 1. Number 2, you reckon number 2 has got a pathogen? Would you like to guess which one? Anyone else got any suggestions? So I don't know if Neil Gutmanstad's here, but he might have some idea. If I flick to the next slide, this is the results. That's the raw tubers that I mentioned previously. This is when we fry them in New Zealand, and this is the typical symptoms we get from zebra chip. And Neil may have mentioned, and that's particularly prevalent in the US. In New Zealand, we get very big issues with the fact that in raw tubers, we don't see symptoms when we know that we have the pathogen present. And this is the result when you have the pathogen present and you fry. So in New Zealand, this causes a problem for industry, primarily because our exports, when we export, they're for fries, and so they're only partially fried at best. And so this result is only observed when we get to market, and so that can cause us a real issue. Okay, so again, we talked about the amount of soil in a field, and then when we're looking at trying to control disease, this is pane 1, 2, and 3 of soils. Can anyone suggest whether any of these are harbouring a pathogen that may cause us an economically important disease? I suspect we probably wouldn't. So really, this is just, if I flick to the results, these are the results of those 3 soils. And this is these are the results. So this is just an example of tubers. So the first one, pane 2, as you can see, would produce tubers which were showed no obvious. Is this working? There we go. No obvious symptomology. Then you've got in pane 3 here. This is a typical black scurf symptoms that we observe. And this would obviously be an issue for our table growers and for our seed growers. This is caused by Rhizoctonia fungus. I'm sure that many of you know that, Rhizoctonia solani. This disease here, this is actually caused by Rhizoctonia solani as well. And so this causes a problem more for our processing than, say, this would. Okay, so when we look at those soils, even if we were able to identify by standard techniques the different Rhizoctonia, that Rhizoctonia was present, we may not be able to determine which forms. So hopefully I've demonstrated that the use of alternative diagnostics to visual inspection and standard processes would help us to identify the presence of a particular pathogen and to allow us to assess whether planting in a particular paddock with a particular lot of seed or other would provide us with a disease symptomology at the end. So diagnostics, as we've just mentioned, are used to support visual inspection throughout the value chain, and from seed production all the way through to at harvest when we're, or even on the line for zebra chip when we're trying to screen out those fries that have got symptoms. And this is just an example of where diagnostics, and in particular I'm going to talk about molecular diagnostics. Now, when I talk about molecular diagnostics, I understand molecular diagnostics have their limitations as well. And these molecular diagnostics really are probably part of an integrated diagnostic process that includes visual inspection and can actually include other technologies as well. But in terms of molecular diagnostics, that's the area that I know the best, and that's what I'm just going to discuss because it's used quite a lot to support potato production in New Zealand. So again, this is the symptomology that they observe in raw tubers in the US. And as I mentioned, we only get this with severe cases. So this obviously was found in New Zealand in 2008, and the presence of this in both potato and in other solanaceous crops caused the complete block of exports into other markets. And so as part of the industry response, there was a political response, obviously, but there was also the fact that we had to set up to be able to show areas of freedom. And so as part of the areas of freedom, this bacterium, as was mentioned before, is not culturable. So standard techniques to identify the presence of it may not work. And so we had to set up an accredited lab to actually do the testing ready to show areas of freedom. So that was just to help in the initial response. Then we actually have been doing work to develop diagnostics to help growers understand risk associated with tuber-borne inoculum of Libiribacter. Now in the US, what they suggest is when you see zebra chip in the tubers, you don't get any sprouting. So effectively, it's a all or nothing. What we know is when you get Libiribacter, depending on its concentration, can cause different effects on yield. And so this is just some results from some work that we've been doing. This is the results of planting 600 tubers in 2 different locations, so the red and blue, 300 of them positive, 300 of them negative, and we quantified the amount of DNA. This is the amount of DNA. You don't need to understand what it means. It's just from lower to higher. This is just one of the growth parameters we measured. So this is growth of the plant in the first 42 days. So we've also got symptomology stuff for at harvest. And what we know here is we get this sigmoid curve, which demonstrates typical of a disease, where at certain levels we might not see any effect. Then we get this gradual progression of disease development with the increasing amount of inoculum. And then here we know if we planted something that had this much inoculum, we're likely to get a very serious effect on our crop. So this is providing some risk assessment tools potentially for our industry. So then in New Zealand, we have a very, very small export market for fresh tubers. And we only export really to certain markets, mostly in the Pacific and into Asia. Now, along with that comes trade barriers. And one of those trade barriers tends to be PCN. So we have to show areas of freedom. So this is the kind of theoretical, what we do is we try to identify cysts, potato cysts from soil. So you're trying to sieve that out and have a look at it. And these are typical cyst shapes. And these include both PCN and other cyst nematodes, these kind of structures. So that's the theory. This is a visual inspection, and this is what we found. As you can see, 2 different shapes. Could be any kind of cyst, or well, we would suspect it would be a particular cyst. But what we need to do and what we use is molecular diagnostics to confirm these identifications. So this is just molecular diagnostics. This is sample 1, 2, 3, 4. And just standard PCR. Many of you will be aware this is no great shapes, but it's important to industry. This is identification, this large positive band, this white band. This shows the presence of Rostockiensis in our soil sample. This shows the presence of pallida. Interestingly, if we come back to this, when we did that assessment, it was neither of these 2 phytosanitary issues for New Zealand export. And therefore, this lot associated with these cysts was able to be sent to overseas. So that's just some examples of how New Zealand is using diagnostics. But there are limitations, as I mentioned, and at the R&D level, there are numerous issues. John alluded to the sampling issue, and the fields are big, and our ability to sample is very small. And so there's a lot of work being undertaken to try and assess whether what we're sampling in the lab actually represents what's in the field and the risk associated with that. But this causes a major issue. The other one is sensitivity. Certain assays aren't as sensitive, and certainly with Libiribacter you can get very low levels that cause an effect. So sensitivity can be a problem for us too. And then one of the big ones is our lack of understanding of a lot of the biology of these pathogens. And trying to link, when we identify the presence of a pathogen, trying to link that to the basic biology and the risk associated with what will happen in the paddock can be very difficult. So even if you tick all those off, actually commercializing a diagnostic can be a significant problem, especially in small industries such as those in New Zealand. So it always comes down to cost benefit. It can be costly to do these kind of diagnostic tests. So a grower will only do it if there's a significant economic benefit to doing it. In addition to that, you've also got the commercial provider. And the commercial provider will also do the same thing. He will only set up a diagnostic if there is a long-term commercial benefit to that diagnostic tester. So, for example, in New Zealand, it's very difficult to establish diagnostics that are at a commercial level. One of the examples is PSA, which has affected kiwi fruit in New Zealand, one of the major horticultural crops in New Zealand, and a diagnostic has been set up commercially for that. But even 6 months to a year afterwards, there are some suggestions that that diagnostic will not be viable due to intermittent use by growers. Then the big one is speed of testing. Obviously, we're all under pressure to produce as quickly as possible results, and the present testing tends to go back to a lab and take some time to do. So with those things in mind, does diagnostics, and in particular molecular diagnostics, have a place in the future of potato production? And so what we're looking at here is just trying to look at some scenarios that would mean that diagnostics would have a place. And so, for example, technology is allowing us to automate all these processes, and at the same time, labour is getting more expensive. So the suggestion might be that at some point, that tipping balance, where it becomes cheaper to do automated testing, might occur. Then there's the time constraints, and this is about if we could get in-field diagnostics. From my perspective, I believe this is the big one. If we could get good, solid in-field diagnostics, that would be the way to go. And so in particular, when we come to molecular diagnostics, there are some tools being developed and in the process of being developed at the moment, and we've started to look at those in the field that will allow us to do certain diagnostics, not all diagnostics, but just to assist growers when they're doing their visual inspections. Then the reliability of the test. And as we do more science on each of these pathogens, we learn more about them. And so we can start to understand, as we did with the Liberibacter, when we've got it present, what actually is a consequence in the field or to the plant. And then, I'm not wedded to DNA-based tests. Are there alternatives? Thermal infrared is one. Thermal infrared techniques have been used to differentiate the presence of PSA, the bacterium that causes severe economic issues for kiwi fruit. That's been used, this thermal infrared has been used to differentiate plants with and without the pathogen. And there are other techniques as well that I won't go into. So, just as I sort of come to an end, really I just want to make mention of the International Potato Diagnostics Collaboration. And this is really just to demonstrate what researchers are doing to try and develop diagnostics will allow growers to actually assess risk in the field. This is a fantastic collaboration that was really set up by the industries in all these 4 different countries, industry representatives, and it brought together scientists in a very informal way. And each of these different countries has a different ability to do research as at different stages in their research development. And so it really was on a, I guess you scratch my back, I'll scratch yours. And the idea was to just bring ideas and new developments to that, to the ability to do these testing of, to do in-field testing of soils prior to planting that would allow us to quantify the risks associated with the presence of a pathogen in that field. So what did we get up to? Well, one of the main things from New Zealand's perspective, we were very much at the beginning of testing in soil. So what we wanted to know is whether our tools were adequate enough to be able to do testing in soils. So we were involved with other members from all those different countries in testing our ability to pick up pathogens in soil. And so FERA, one of the members of the collaboration, produced soils which are artificially inoculated with different pathogens. And then we were all asked to detect that pathogen in that soil. So they did different levels of inoculum, and then they sent it to us, and we had to pick up DNA. So this is high to low inoculum levels, and this is our DNA detection. The blue line is actually a line that represents the average that we picked up, and all the different symbols are for each different lab. And as you can see, what we found was actually we were relatively consistently picking up certain pathogens in the soil. So that was the first thing for us. That was great news. And what it's allowed us to do is to move on to start assessing the pathogen in the soil, in the field, and also on tubers. So for example, in New Zealand now we can actually differentiate whether Rhizoctonia is present on tubers and this is just a certified, so it's gone through the certification scheme, and this is non-certified. This was rejected as part of the scheme, and it's just to show that we can differentiate the amount of Rhizoctonia inoculum. Why is this important? Well, you can see here that sometimes you do pick up inoculum, and so is there a risk of having some Rhizoctonia on that certified seed, and how can we improve our testing and our cleanliness? So how does this all affect growers? We're trying to develop research. Well, the Australians and the guys in the UK are doing an enormous amount of work, and some great work, actually going into the field to try and establish whether we can assess risk. So what they've done is they've done a large amount of work on sampling strategies, and they've gone into fields and they've tried to assess whether they can pick up Rhizoctonia solani and Spongospora, and then establish whether they could predict risk. Or whether they could show an increase in disease development. So what they found, though, was with Rhizoctonia, and that's been a frustration for the group I know, is that this interaction between inoculum level and disease is very complex and it's hard to predict. But what they have found is that they can detect, when they detect powdery scab at different levels prior to planting, they see different levels of disease development at the end of the season. So as you can see here in 2 cultivars, with increasing inoculum, you get increasing amounts of disease in both cultivars. So I think that the British are now providing this as a service to growers, and there is some discussion, if Kathy's here, about commercialising that in Australia too. So with that, I'd just like to take any questions.
Okay, thank you. Right, ladies and gentlemen, thank you, Andy. That was fantastic. We're going to do a bit of a seat swap now, so I'm going to invite both John and Andy to come and sit up here, and I'll stand over there. We then have 10 minutes for questions, and they do need to go through the microphone. So, if you guys get comfortable, we will begin. Do we have any questions? Yes, I'll take this one at the front, and then we'll go over to
Thank you. My name is Kamasi. I'm from Tunisia. I thank my colleague for their presentation. The problem still, if you guarantee a good quality here, when it goes to the farmers in the other part of the country, so you lose this quality because everything is mixed there. So I propose that this traceability had to continue to the end user. I explain. Like in Tunisia, we have a seed from everywhere, from different countries, from different companies in the same country, and we have different representatives, so different importer. They came as lots, but those people sell those potatoes, those seeds, mixed. The people are cutting, they don't make what we call the crop rotation and so on. So this and with the problems, commercial problems, the farmer said this is because the seed have diseases, and the importer said no, it was controlled and I have no problem. The exporter said the same thing. So we propose that I see that there is a big collaboration there. It's simple. So when seeds arrive in Tunisia, like take an example, we can get those seeds as lots. We take samples from those lots and we make a big control fields. The representative sell the seeds as lots, so we can control the origin of the problem. And we did this, I think, this year as an experimental way, and we solved so many problems. And we detect the origin of the problems. We have seed with black lag in the same from the same exporter in 1 or 2 lots, and so on. So also the company that sells this seed can have can know the origin of the multiplier in their country. You have a bad multiplier, bad. You understand?
Sure.
Bad,
Yeah.
Okay. I hope you understand what I mean. Thank you.
So, John, perhaps if you were to say something about the mice buds and how we're looking at traceability seems to be the issue here, and how we understand where stocks are going, that might...
Yeah, so what the gentleman says is quite right. You must, the key to the certification process and achieving quality for the end grower is to know what he's growing. So the way that should work in practice is that the grower should have the label that is attached to the seed potatoes. So he should be able to get labelled material in a bag which is sealed. That is the ideal position. But of course now we have more use of ton bags, so exporters ship in larger quantities, and then there's some division before the end customer. And that theoretically and in practice shouldn't happen, but of course in some countries some growers take a very small amount for their own use, and then, as you say, mix-ups can happen. But as soon as the material is out of its bag, when the seal is broken, then the material has lost its identity, and then nobody can have any recourse to complain because the seed is no longer seed. So the key thing for the buyer is to make sure that they get the seed with the label attached.
This year we have
sorry, can you use the microphone so we can record? Thank you.
This is right when you have 100,000 or 200,000 tons. In Tunisia we have 20,000 tons of imported seed. It's 400 lots. And we take only 50 kilograms from each lot, and it goes very well. The problem is the representative is not participate in this to continue the chain, so till the farmer, but still something which is not very complicated. It is really guarantee the quality. So seed from IPI must be good. So why we mix it with seed from Netherlands or France or Germany? So this is my idea. So
no, you're right. You're right.
I think it's fair.
We have here a consortium, so we can put it in a good way.
Okay, thank you. Thank you for the comments. We had a question over here from Debbie.
Hi, Debbie Winstanley from PepsiCo. Given the challenge of blackleg in commercial crops, what are the current opportunities to develop commercially diagnostics for blackleg identification within seed lots?
Andy, do you want to take blackleg?
Standard blackleg, not anything fancy, just ordinary blackleg.
So I guess I'm just looking around to see if a couple of the people from the other countries are here, because there's, is Jerry there? Yeah, Jerry's there. Jerry might be able to describe this, because obviously in Scotland it's a big issue, and I know that they're sort of working towards some, well, they do have diagnostics.
We do have diagnostics. The problem is, what do they mean, really? So it's actually using the diagnostic in a predictive sort of way, which is an area I suppose we've been stuck on really for a number of years. So for sure, if you have a seed lot and it's got no atroseptica in it, then you're not going to have blackleg in the sort of the following year. And if you've got a lot of atroseptica in the diagnostic, then there's a good chance you're going to have blackleg in the following year. The problem that we have is what happens in the middle, where you have sort of, a certain amount of atroseptica. And it's incredibly difficult, actually, to then make a prediction as to what happens next. So I think and that's probably one of the weaknesses of diagnostics, and I don't know whether you'd like to sort of take this on further, Andy. It's actually translating what you find from the test as to what's going to happen next. That's the big weakness, really, with this.
Absolutely, especially for uptake from growers. You have to have a reliable test that you can assess risk with. I guess what we've been trying to do with the Liberibacter, for example, with that seed inoculum, is to try and demonstrate whether there is a relationship between the amount of inoculum and disease. It's slightly different to blackleg, because blackleg is more persistent, and I'm not sure in terms of research where that kind of work in the field has gone, looking at multiple generations when you get a certain amount of blackleg in the original stock. That would be probably where I would be going initially to back up any commercial diagnostic, because you have to, as Jerry says, you have to have the ability to assess risk and to provide the growers with some understanding of what the result means.
And can I just add?
Yeah, sure.
I think in terms of the question and how we might take it forward within a certification scheme, I have some reservations about using a test in a certification scheme, because when you draw your sample and do your test, if you do that before there's a condensation event and then something happens between the sample being drawn and the customer getting the material, particularly if it sits around in ton bags in inappropriate storage conditions, then the outcome for that crop can be dramatically different. So timing is an issue as well. I don't want to put Henk on the spot, but maybe you want to say something about that? No? From a point of view of the other schemes? I didn't want to put him on the spot, but I clearly did, so sorry, Henk.
No, but that's exactly the discussions that we are in with our seed sector. Where now we will carry out this year a big trial on testing for blackleg in the highest seed stocks, and an evaluation by the end of this year, beginning next year, must make clear whether the results can be used in our certification scheme. And we are also fighting with the question about should there be any relation, a clear relation between what you find in the lab and the result in the field. And it's very understandable that farmers want any relation, because in the past we have done tests, and when farmers did not find any disease symptom in the field, and we downgraded on the basis of a test, then that's a difficult discussion. So we are in the same field of uncertainty, so to say.
Okay, we have time for one more question. I'm going to come to Kevin there. Thank you.
John, just one of the real serious issues I think that seed certification faces, and it was touched upon by the gentleman from Tunisia, is the temporal variation in disease progression from the time certification might occur, which can be immediately after harvest. It can be then several months or longer before that seed's ultimately used. We've had this discussion about Erwinia. We already know that there's a lot of variation in varieties in terms of their resistance or ability to tolerate Erwinia. Some, if you see it in a crop, you have to get rid of it immediately, others will last longer. And the same goes for a lot of other diseases. I wonder how certification authorities can deal with this kind of temporal variation, whereby you can inspect crops at certain levels, it goes somewhere, but we really are at a very poor level of predicting potential future progression of disease during transport and storage. And that to me is one of the real issues that we need to face if we want to have a, if you like, a global scheme.
Yeah.
Care to comment on that?
So you are of course quite right, but from the certifying authority's point of view, the position is quite clear that we give an opinion of the quality of the material when we inspect it, which is at the point of marketing. So as you saw in the slide with the inspector, when he's doing his inspection, that's immediately before the material's loaded onto a lorry, and it could go just down the road and it could be just before harvest. But as you quite rightly say, it could go half the way round the world and then sit in a store somewhere waiting to be planted potentially months later. So I guess the real thing is to understand when you take, as a grower, when you're taking the material, you're also taking the risk. So when you buy the material, it might be in good state, but if then you abuse it, if you leave it in the bags on your farm to sweat and don't store it properly, then, and it melts when you plant it, then that's because you didn't do your job properly as the grower. So you've taken on the risk, even though at the point of control, it passed inspection. But there is an additional problem that it may be that it's been just graded, and then there's degeneration of the quality immediately after the inspection during transit, and of course that does happen. So we have problems occasionally with rots after the certification. The authority said it was okay, when in actual fact it subsequently broke down because that was already triggered by the grading event, and then it passes on to the customer. But I guess we do what we can, and we live in an unperfect world, and I guess it's making sure that everybody understands that. The certification process is quality assurance, it's not a quality guarantee, and then we have to cope with the problems.
Okay, thank you. Right, I'm going to draw this session to a close now. I know there were a few more questions, so there were a few more hands up. I know John and Andy will be around for the rest of the day, so have a one-to-one chat. I said this session was down to the quality of the questions, and the discussion was down to you. Thank you for your participation. I think they were good, earthy questions that put you on the spot a little bit. That's good. Just to finish off then, John, best of luck. You are treading a fine line during an uphill struggle, so well done with that. And Andy, there is no way I'm taking a bet with you. Okay, so well done, guys. Thanks.